Let me show you something interesting. I have got an ultraviolet flashlight here, and I am standing on a rock made of limestone. Calcite, gypsum, and I think that this calcite glows under UV light. All we have to do is to wait for darkness, and we'll check it out together. All of this is limestone. And it's totally possible that this entire rock, maybe parts of it, fluoresces under UV. Now, look over here. There is this little pocket with crystallization. See the crystals? I'm not sure if they are gypsum or calcite. I'll try shining the UV light here once it gets dark. Let's see what happens. But while we are waiting for nightfall, let's explore a small cave nearby. Right at the entrance, you can feel the temperature drops sharply. It's chilly in here, around 5 degrees Celsius. There is actually some snow or ice here, though it's a mystery where it came from. But the most interesting part is the walls. What's this cave made of? Its main building block is gypsum. Gypsum is scratched easily, and it incredibly loves water. Or rather, water loves to dissolve it. How did this underground kingdom come to be? Let's rewind time by millions of years. Once upon a time, an ancient sea rolled over this area. Organisms died and settled to the bottom, and as the water evaporated, it left behind thick layers of salt and gypsum. Eventually the sea receded and dry land formed. But the water didn't just vanish, it began seeping through cracks in the ground. Scientists call this process karstification. Regular rainwater or meltwater soaking up carbon dioxide from the soil turns into a weak acid. For gypsum that's more than enough. Century after century, drop by drop, the water dissolved this rock from the inside out, expanding tiny cracks into massive chambers. It also carved these wonderful patterns on the walls that look like plates, ribs, and even sound like musical instruments. Well, darkness has fallen, so let's go and see if we can find something interesting. Wow, look at that! I knew it! This calcite glows under UV light, like burning embers. Let me turn off the UV light and switch on a regular flashlight. Look at how it appears now. This is the exact spot, our pocket with crystallization. Look at them. exactly like little embers. They are pretty cool, but I don't collect them, because I don't really know what to do with them. So please, drop a comment below if you have any ideas about that. Look, that one is glowing too. There they are. So beautiful. And here is normal light for comparison. There it is. This is the one that was glowing like a hot coal. Oh, here is another spot. Wow, even my fingernails are glowing. Look at those embers. Gorgeous. Oh. They are locked tightly in the bedrock. Whoa, look at that massive boulder. The whole thing is glowing. This huge rock is all covered in embers. It totally lit up. Oh. Damn, climbing around the slopes at night is something else. A cliff behind me, a rock wall in front of me. But man, it's exciting. Like little fireflies. Over there too. Oh, here is one lying around. Huh, no, it's attached. But this one is loose. Seriously, what do I do with them? They are just beautiful under UV light. By the way, maybe I should mail some to my subscribers, if anyone's interested. This is what this specimen look like in daylight and under UV. This definitely isn't sodalite. Sodalite is much harder and looks like a granitic pebble. Sodalite, or as it is also called euprolite, takes a polish beautifully. It makes gorgeous cabochons that look like mosaic cyanide under normal conditions but turn into burning embers under UV. But this right here is calcite, and it's easily broken. Calcite has a Mohs hardness of 3 and it can be easily scratched by any metal object. However, that doesn't detract from its visual appeal at all. It can absolutely hold a worthy spot in any collection. Well, that's all for now. I hope you enjoyed it. Make sure to subscribe to the channel so you don't miss out on any interesting finds. Bye bye!